Welcome back to the lesson on data integrity. This topic is now an introduction to the ALCOAplus principles. When we perform an experiment, there is a process we follow, and the following slides I will explain the different aspects of ALCOA and its importance along the experimental chain. Normally we start with the experimental design or planning stage. Then we prepare samples or perform the experiment, which results in data acquisition. These raw data have a special role, as explained in the previous presentation, and need to be stored somewhere. The raw data is then analyzed, and ultimately the entire experiment has to be documented and archived for long-term storage. If you are wondering what the difference is between data storage and archiving, this will be clarified as we go through the different aspects of the acronym ALCOA. The first letter of ALCOA stands for Attributable. That is, who acquired the data or performed an action. Basically, it means that the originator of the data must be uniquely identifiable. There must be a written record of this, and that this must be ensured throughout the entire experiment. Adherence to this principle means that names or initials of the researcher are added to the records, for example in a lab notebook, in the file names or folder structure, and that can be any format. This might sound complicated, but it is particularly important with collaborative projects, where a naming convention across collaborators should be agreed on. The second letter stands for Legible. That is, can you read and understand the data? This is important because it allows a full reconstruction by others interested in your records. Legibility should of course be ensured in everything you do in the lab, but I consider it most important when storing and archiving data. To adhere to this, it is important to take care of one's handwriting so that it can be read by others. It is important to use a common language in the lab. For example, in international labs, all lab notebook entries should be written in the same language. But also think of digital data. It is important to ensure that the file is widely readable and in a format that will be readable still in 5 years. Contemporaneous means that the data must be recorded when it happens and that no backdating should occur. Therefore, it is best to always document immediately or have dedicated times, for example at the end of the day or at a specific reserved time during the week. It certainly should not be postponed longer than this. Documenting in a timely manner, of course, applies to all aspects of the experimental chain, but it is most important for sample preparation and data acquisition. For example, if you are performing a time course and using reagents that are not very stable, delay can negatively affect the outcome of the experiment. In this context, it is important not to backdate certain activities, as it could give a false impression. Maybe that is also something for you to reflect on. When do you document your experiments? The O in ALCOA stands for original and asks whether all research data are saved in the original format. Meaning, are the raw data saved in the exact same way as recorded, and in a way that cannot be altered? This is especially important for the storage of raw data, as it must never be changed and should always be saved in read-only mode. This is best done directly after acquiring the data, which means it is safe and can undergo multiple analysis and later be linked to the archived documentation as original files. Data should also be accurate, meaning that data should be recorded correctly and truthfully. In practice, this should be done for all aspects of the experiment and study, and I suppose everybody is interested in working accurately. However, errors happen and might be overseen. Therefore, it is in everyone's best interest to briefly reflect on accuracy when documenting and before closing a file. Depending on the needs and structure of your organization, this could even be done by a colleague who just double checks that nothing is missing. For example, in our team at PASP, for some items we have established a 4-eye principle, meaning that another pair of eyes reviews important documents. Now we come to the 4+ principles of ALCOA, which starts with complete. This applies to data analysis and asks whether all data are included, such as any repeats, outliers, which was discussed in a previous lecture, controls, markers, or pre-analysis, and so on. Meaning, are all steps of the experiment and data included in the documentation, such that other researchers could reconstruct the experiment. The data should be consistent, meaning that all elements should be in chronological order and as planned. This again applies throughout the entire experiment. If contemporaneous documentation is followed, all items are in chronological order anyway. Therefore, this could be another item to double check during documentation, just like accuracy. The next and second last principle is endurable, which applies when archiving data, as records need to endure for X number of years. I would assume that this principle would be rather ensured by the IT infrastructure in your organization than by you. However, it is still important that you at least follow up on how your data are stored and backed up for long-term storage. This brings us to the last item of the ALCOAplus principles, which is about the availability of data. Data need to be kept in a format that can be accessed for review over the lifetime of the record. For example, raw data presented in a graph within a publication should always be available. This can be tricky, especially in the context of different file formats, or also physical storage media. For example, many computers do not have a CD reader anymore. In many cases, this will also be the responsibility of the IT department or similar infrastructure within your organization. But it is also something for you to think about when using very specialized software to read raw data. This slide is a summary of the ALCOAplus principles on data integrity, which is promoted by the FDA and WHO. Please read through these questions again and think now for yourself. Are your research data positively fulfilling these questions? Do you see any issues when answering any of these questions? And what would be needed to overcome these issues?